equals 17.15. Now let's recap what we just figured out. We were dealing only with the y direction, and we determined that it impacts in the y direction down here at 17.15 meters per second. So that impacts 17.15 meters per second, and that's only in the y direction. Now what about the x direction? Well, the x direction is simple. Nothing hindered the x direction the entire time. This object has been moving in this direction at the same velocity throughout the whole process, which is the originally calculated 17.32 meters per second. And since that doesn't stop until it hits the ground down here, just like this doesn't stop until it hits the ground, you leave that 17.32 meters per second alone. So then what you get is a final triangle. And this is the triangle of velocities and the components when it hits the ground. So you know in the x direction, like I just said, hasn't changed throughout the whole process. It's still 17.32 meters per second. Your y direction is what we just calculated throughout that whole process below the dotted line, which is 17.15. And you use the Pythagorean theorem, this squared plus this squared equals this squared. And so you take the square root of that using the Pythagorean theorem, and you find that this hypotenuse is 24.37 meters per second. And that is the velocity at which it hits the lower surface in the canyon of the cliff. If you want, you can continue to calculate the angle that this happens. So what you can say is you figure out this theta, which is equal to this theta. And what that is you say theta equals, I'll use tan, and since tan is equal to opposite over adjacent, opposite from the angle over the adjacent angle, adjacent to the angle leg value, equals the tan inverse of this, opposite 17.15, over adjacent 17.32. And you use the tan inverse when you want to find the angle. You just use tan when you already have the angle. So you can do this in your calculator, and you end up getting theta equals 44.72 degrees, which makes sense because the legs of the triangle are almost identically the same value. And if they were, this would be an angle of 45 degrees. If two legs of a triangle are the same length, then the angle becomes 45. Well, this one's slightly less, so it's slightly less than 45 degrees, 44.72. But you have to keep in mind that when you're talking about angles, you can't use 44.72 because that's this angle right here. When you're doing it in the Cartesian coordinates, you need to describe it in terms of this angle from the horizontal line in the first quadrant. So to figure that out, you just simply do 180 degrees minus 44.72 degrees, and that gives you 135.28 degrees. So although you're probably only going to be asked for this, which is just the velocity, you can continue to say that it's going to be 24.37 meters per second at an angle of 135.28 degrees. So this is your answer.